What's happening, dogs? Mr. Allen here, about to evaluate 6 dope trig functions using the beloved unit circle that I have sketched partially over here in the top right-hand corner. Now, there's a few different ways of using the unit circle to evaluate trig functions by hand. I got a few steps to the method that I prefer, and hopefully it's your preferred method by the end of this video, okay? So first thing here, I don't memorize the entire unit circle. I just have the first quadrant memorized, and here's how you can remember it, okay? So your x-coordinate, which is your cosine, okay, starts out at root 3, then root 2, then 1. So 3, 2, 1, they're always over 2. All right? Then the sine is just the reverse. 1, 2, 3. But we got the root and the root over the 2 and the 3. Okay? So it's a usual way of people seeing those things. Okay? Now, the reference angles, it's 30, 45, 60. Your 30 reference is over 6. Your 60 reference is over 3. I know it's kind of a little bit weird, but your 45 is pi over 4. All right, so all of your references in radians, if you just look at the denominator, you know what the reference angle is. If it's in degrees, you got to do a little bit of, subtraction and stuff like that to find your reference angle. Okay, so once I figure out what my reference angle is, I can get my value, all right, and then I can determine if it's positive or negative using what I know about the quadrants. All of my trig functions here are positive. Over here, sine and its reciprocal cosecant will be positive. The others will be negative. Here, tangent and cotangent are positive. The rest of them will be negative. And then cosine and secant, its reciprocal, will be positive in the fourth quadrant, while the others will be negative. All right, enough talking. Let's get going. We got cosine of 60. So 60 is my reference. Boom, it's 1/2. That's it. Nothing to that one, right? It was the first quadrant. Cosine's my x-coordinate. It's 1/2. Lovely. Tangent of 7 pi over 6. All right, so my reference, we're looking at the 30-degree reference or my pi over 6 reference. Tangent is, this is a tough one right off the bat, man. It's sine over cosine, okay? So we're going to go ahead and do sine over cosine. So my sine value is 1/2, okay? Sine value is 1/2. And then instead of dividing by the cosine value, I'm going to multiply by its reciprocal. So the reciprocal is 2 over root 3. So that's for tangent, okay? I'm not worrying about the positive or negative aspect yet. We will get to that in a moment. So the 2's cancel, and I'm left with 1 over root 3, which we have to rationalize by multiplying by root 3 over root 3. So I get root 3 over 3, okay? Now my final answer comes from what quadrant it's in. 7 pi over 6 is into the third quadrant. Tangent is positive in the third quadrant, so this will remain root 3 over 3. Now, it seems kind of like a lengthy process, but with a lot of practice, you start getting better at these things, move a little bit faster, okay? You can also sketch special right triangles and hit it with some SOHCAHTOA or CHOSHIKAO if you prefer. I actually like that method, but the unit circle does move really quick with practice, okay? Next one here, sine of 5 pi over 4. My reference is the 45, right? It's the over 4, the 5 pi over 4. So I know I'm dealing with this one, which means it is root 2 over 2. Boom. Now, where is 5 pi over 4 located? Well, 5 pi over 4 is in the third quadrant, right? It's a little past pi. 4 pi over 4 would be pi, so a little bit more. Boom, we're in the third. Tangent and cotangent are positive, which means sine has to be negative. So there's my final answer. I never circled the 1/2. All right, there we go. Beautiful. Lovely. Okay, so got my value, then I decide if it's positive or negative. That's how I go about it. All right. Cosecant. Ooh, a reciprocal. Cosecant of 240. All right, so 240. That's a 60-degree reference, right? 180 is where you're looking at your reference from, so it's 60 degrees away, okay? So 240, reference is 60. Now, cosecant is the reciprocal of sine. Okay, so we're looking at sine here, my y-coordinate. Well, my y-coordinate would be root 3 over 2. Flip that, we're going to get 2 over root 3. Now I got to rationalize it. So I'm multiplying by root 3 over root 3, so you're going to get 2 root 3 over 3. You'll see the same kind of values every single time in these problems because we're using the same 3 fractions, right? So you're going to see a lot of the same rationalization that's occurring and stuff like that. Now, is it positive or is it negative? That's the question. 240 is over here in the third quadrant. Tangent and cotangent are positive, which means sine, cosecant, cosine, secant are all negatives. So my final answer here is negative 2 root 3 over 3. Boom. Diggity. All right. I'm going to change colors. I know I've used pink this whole time. I kind of want to go to blue. I'm going to blue. All right. Making the call. So we got 5 pi over 3. it's kind of nice when it's in radians and you know, like your reference, like you got this guy right here, like boom, pi over 3. That's what I'm looking at, right? So that is kind of nice about radians here. I know it's like a weird measurement, but whatever. All right, so 5 pi over 3, right? We're secant, which means that's the reciprocal of cosine. So I'm looking at my x value of 1/2, but it's the reciprocal, so I got to flip it to 2 over 1 or just 2. But now I got to decide, is this positive or negative? 5 pi over 3, that's in the fourth quadrant, right? Because 6 pi over 3 would be 2 pi. So 6 pi over 3 is a full rotation, so we're a little less than that. We're in the fourth quadrant here. Secant is the reciprocal of cosine, which happens to be positive. So positive 2 is my final answer. Boom, done, dope, awesome. Sixth one here. Whew. A lot of examples here, but with practice, like I said, you get pretty fast with the unit circle. Okay. Cotangent, 135. That's a 45-degree reference angle. Cotangent is the reciprocal of tangent, so we got to flip this. It's going to be cosine over sine. So cosine is my x value, right, which is going to be root 2 over 2, and then I'm going to multiply by my reciprocal of sine, right? So we're dividing by root 2 over 2, and you might already see where this thing's going here, but we got 2 root 2. Everything's going to cancel. It's going to end up being 1. So don't really necessarily have to write that one out with the multiplication like I did earlier up here, right? Because it's going to be, anytime it's a 45 reference with cotangent or tangent, it's going to be 1 or -1 because you're always doing something divided by itself with that one. And that's another pattern that you're going to catch on to kind of quickly as you're going through these processes, right? The 45 reference for cotangent and tangent, 1 or -1 real quick, okay? Is it positive or is it negative? Well, 135 is over here in the second quadrant. Sine and cosecant are positive. Everything else is negative, including cotangent. Boom. Wonderful. 6 dope examples. Unit circle. I mean, it takes some practice, guys. Big tips here. Okay, big tips. First off, cosine is your x coordinate. Sine is your y coordinate. Right? These little 1, 0s, that's your quadrantals. So if I said, what is sine of pi over 2? That'd be up here. Sine's my y coordinate. It's 1. What's cosine of pi over 2? It's 0. Okay? Those would be quadrantals. Another video or something like that on that. Okay? Memorize your first quadrant or know how to lay it out. Maybe even write it down on your paper early on. Hopefully by test time you don't need to do that. But you can always throw it down there. That way you can do a quick visual check. But get your first quadrant. Then you deal with your signs, positive or negative, right? Everything falls here from this first quadrant and a little all students take calculus ASTC action right there. All right, man. That's about it. That's dope. Super awesome. You guys are dope and super awesome. And I hope you enjoyed the unit circle evaluating trig functions awesomeness video.